Hello there. In today's video, we're going to talk about using the discriminant. So if you have an equation in the form ax squared plus bx plus c equals 0, also known as a quadratic equation, you can use this little formula, b squared minus 4ac, to figure out what the answers are going to look like. And another name for answers in this situation is called roots. So if I give you an equation, instead of solving it, you could just use this to tell me what would the answers look like. That's useful. Sometimes you don't have to actually answer a question. They just want to know what kind of answers we're going to get. So if you use this b squared minus 4ac, and you plug in the numbers a, b, and c, and then you evaluate this, if the answer ends up being negative, then you know your answers, you know your roots are imaginary. So it says if b squared minus 4ac is negative, then we know our roots are imaginary. All right? If b squared minus 4ac is 0, we know that our answers, we know that our roots are real, which is the opposite of imaginary. And we know that they are equal. And another way to say that is there's only going to be one root. Quadratic equations usually have two answers, usually have two roots. But if you use b squared minus 4ac, you might end up with a situation like this, where you're only going to end up with one root. Okay? In this one, we have 0 real roots. In this one, we have 1 real root. And then the last two situations, if b squared minus 4ac is positive and it's a perfect square, like 1, 4, 9, 16, 25, so on, then we know our roots are real, unequal, which means there's going to be two different ones, and rational. Remember, a rational number is a decimal that ends or repeats. Or another way to say it, a rational number is a fraction, a number that can be represented by a fraction. And then finally, if b squared minus 4ac is a positive, non-perfect square, then our roots are going to be real, unequal, and irrational. Now, before we do an example really quick, let's just talk about this discriminant. This should look familiar to you. That is because it's in the quadratic formula. If we bring our little poster in here, our quadratic formula has b squared minus 4ac in it. So all we're really doing is figuring out what's going to happen when we square root this stuff. If it's negative, well, that'll make imaginary. If it's a perfect square, well, that'll make a nice answer that's rational. If it's not going to be a perfect square, then the square root's going to be, it's going to have a radical in it. It's going to be irrational. And if this works out to be 0, then all of this cancels, and we're just left with this. So that's why we only have one root in that answer, that situation here. So I'm going to move this out of the way. Let's do a quick example here. And just like that, there's an example over here. It says describe the roots of 2x squared plus 8 equals 3x squared minus 5x. Now describe the roots. They're saying, hey, you don't have to solve this. You don't have to find what the answers actually are. We just want to know what the answers would look like. So let's start by putting this equation in this format. And to do that, we're going to get everything on one side so that's equal to 0. So we're going to do minus 3x squared. Actually, let's do minus 2x squared. Let's put all the stuff on the right here so that our x squared stays positive. And then that means let's move the minus 8 as well. So that means this side's going to be equal to 0. And this will be 3x squared minus 2x squared is 1x squared. There's nothing to go with this minus 5x, so we're just going to bring that down. And there's nothing to go with the 8, so we'll just bring down that 8. And now we're going to use the discriminant formula. A is 1, B is negative 5, and C is negative 8. So if we do p squared minus 4ac, we get negative 5 squared minus 4 times 1 times negative 8. Negative 5 squared is 25. Negative 4 times negative 8 times 1 is going to be a plus 32. These add up to 57. 57 is positive and it's not a perfect square. So that means if we were to solve this problem, we would end up with two real roots that are unequal and they are irrational. So that's all for today about discriminant. Have a good day. Thank you for watching.